Hey guys, welcome back. And today we'll be discussing about Hackerrank question, right? So this Hackerrank question is based on game of theory, and it is called the Game of Stones. So let's start with the Game of Stone. So there are two players, call it Alice, and we have Bob. Let's name them Alice and Bob. And we have N stones, right? So these stones are just there present with them. Now there is a game that you need to take. The game says that you can take 2, 3, and 5 stones, right? So suppose there are 10 stones. You can, any player, for example, Alice, can take either 2 stones from that 10 stones. So remaining will be 8. Or she can choose to take 5 stones or 3 stones, right? So this is the constraint we have given. Now this game is played alternatively. Like first, suppose Alice plays the move, then the player will be followed by Bob. For example, if Alice takes 2 stones, then in the next turn, first turn, and in the next turn, Bob has option to take stones. Now you might be guessing this is a game and who shall win the game, right? And you're right about it. So the person who cannot make further move lose, right? So the person who cannot make any other further move is declared as the loser of the game, and the person alternative to which he's playing is declared the winner. So for example, we have, suppose, call it 1 stone remaining in the pile, and it's Bob turn. So Bob cannot. Players are restricted to only take 2, 3, or 5 stones from the pile. They cannot take 1 stone because we do not have such options. So Bob cannot take any stones, and he will declare the loser, and Alice wins. So I guess you might have understood the question. Now let's start to build up a solution. How? So before building the solution, we are giving the constraint that the number of stones are in the range of less than 100, call it, right? So this is a very good constraint, and this will come handy when we are just going ahead with the problem. So let's discuss about take out the question, what they are trying to say. So I have the question here, and the question says that there are two players, number one and two. They are playing the game of n stones. Player one will always plays the first. So here we can assume the Alice to be player one, and in this case, the Bob is declared as the player two. Right. So up to here, we have just discussed the question and what the question is trying to convey us, and we have the given to constraint that the players cannot remove either. They are restricted to move either 2, 3, 5 from the board, right? And we just move ahead, and we have the value of n to be in the range of we have the value of n to be in the range of 1 to 100. So and the player which wins the game is declared as a winner, right? So let's talk about the base case up here. Let's talk about, suppose we have piles of stone, different piles of stone, right? So let's talk about n. So what happens is that if there is one zero stones, let's start with 0 stones. So obviously, if there is 0 stones, the first player cannot make any move, and the second player is declared the winner. And if there is 1 stone, what will happen is that again we have second player as a winner. Now, what if there is two stones? Now, right, the first player here has an option. He can choose to remove, as we said, we have a constraint that they can only remove two, three, five stones from the given pile. So yes, two is present. So we can definitely remove the two stones, and there will be remaining zero stones. And hence, when it's Bob's turn, he cannot make any move. He cannot make any move. So what happened if Bob cannot make any move? Then Alice is declared the winner, right? And now let's talk about further constraints. Now in the constraint we have, suppose, for it, three stones. Now the three stones, what are the possible options we have here? Again, the first player remove three stones. So the second player lose, and he's declared the winner. For example, we have four stones. Again, we have first player as the winner. Can you guess it why? Because in the first case, we can just remove the. Because here, what we can do is that we can remove three stones. The player one can remove three stones, and then the player two will be left with the option to remove only one stone. But as we know, we cannot remove one stone. So player two cannot make any possible move. So the first player will be again declared the winner, right? In the five stone, what is the problem that we can say that again the first player removed the five value, and again we have the second first player as the winner. In the sixth stone, again it's the first player. Why it's first player? Because if we remove the five again, then he's automatically declared the winner. Now, there is something to be noted. Okay, you might be thinking who shall win the game. It will always depend upon the moves he can make, right? For example, let's take a complicated case. For example, we talk about seven, right? In the seven, there are different options. In the seven, we actually have very different options here. So, what is the possible move? Is that and let I'll just clear the board of you. So, in seven, right? What we can do is that the player one has different options. He can choose to remove 2, 3, and 5. But there is a gist to this question. There is a trick. The player, when will remove such stones, he will play optimally, right? So if given a chance, player one will remove only those stones which will make him the winner. For example, if you remove the five stones from the pile, and originally we have seven stones, so seven minus five, now we have two stones remaining here, right? And Bob cannot. So two stones are remaining. Bob will remove two stones, and player one will lose the game. So we do not want that, right? So what is the just behind this question is saying that if possible, like if I tell you that if there is certain number of move which is possible such that the player one can win the game, player one will play that. For example, now if I remove the two here, we'll be left with five. Again, the Bob can remove the five stone from the given pile, and he will be declared the winner. Right. So what if we remove the three stones from the pile? We have four stones remaining, right? Because if we remove three stones, we have four stones remaining, and Bob will be very smart. He will like, I can remove two stones, or he can remove the four stones, right? So what he does is that he removed the two stones, let's say, for example, and we'll come back to the three stones. So if we remove two stones, then player one will remove two stones, and Bob will lose the game here, right? You can get it because two stones are. See what happened is that first player removes three stones, right? Player one. Now we are left with four stones. Now Bob removes two stones. We and Bob removed two stones, right? How many stones are remaining? Two. and player one will also remove two stones, these two left stones, and right, we have one stone remaining, and he will lose the game. So what I mean to say is that this is the most confusing part of the question. Yes, it is definitely. So, for example, for every state we have already an answer. For example, I call it DP7, right? So for DP7, if I remove two stones, I will go back to the state of DP5, and if I remove three stones, I will go back to the state of I have removed three stones. Here I will go back to the state of four, and if I remove another five stones, I will go back to the state of two. Right. So what we say that if there are different possible answers, right? For the player one, he can only choose these three options. But if he wins the game in any of the three possible outcome, then he can definitely win the game. I hope you're getting what I mean to say. So, for example, if I remove two stones, I go to the state of DP5 and player one is winning, he will definitely choose this state, right? And if the player one uh, is winning in the year, if he loses in the DP5 and if he goes to the DP4 state, right? And he becomes like, yes, I can definitely win this game here. So if he's winning here, then he can definitely win the overall game. I hope you're getting what I mean to say. So in every possible move, we have three different options, right? So for if I am the I state and if I'm at the I state and if I am winning at the I minus 5 value, then I will win the game. But if I lose the game in any of these three states, I will definitely lose the further game because no matter what move I make, I will definitely land up in a case where I previously lost the game. So this is how it works, right? So you have to build up it's dynamic programming, and what you have to do is that you have to build the base cases. The base cases is from DP0, which is the winner of the one. We can declare it one. DP1 will be one. So one is for the player one winning, player two winning. Sorry. Okay. So in this year, we have player two winning, and in other cases like DP2, DP3, DP4, and DP5, what we have is that who's winning the game? It's the first player, so we represented by zero. Now, if I say that if DPI minus 5, DPI minus 2, or DPI minus 3, so these are the only three possible states. So if any of these are true, that means who will win the game? Obviously, the second player. Why? Just go behind. As I said, that if I go back to the different state, right? So if I go back to the 5 value and I minus 2 value, I will be landing in something different values, right? So if these are the 1 1, then definitely I'm at the original state like this. So what happened here is that if it is one, that means the second player is winning. Note I represent player two by one value, and player one is actually represented by the value of zero. So what happened here is that if any of the games here, okay, if player one is winning, we can definitely say that the second player is winning. There's no doubt. But if else, what we can say is that we can just declare the first player as the winner. So the basic logic behind this question is that you have to count up the state. So the basic state is that for every different I value, we have for every I value, I hate this pen. For every I value, we have I minus 5, I minus 3, I minus 2. So if any player is winning at these games, then he will definitely win the game. So for example, if the player is winning at the I minus this value, then he will win the whole game. Otherwise, he will not win the game. I hope you're able to understand this question. I have given the code in the link description, and if you have any other further question doubt, you can just comment down in the link below, and do share with your friends. And thank you, guys.